electron that is ready to abstract H minus, that is a hydride ion, because it is electron deficient one. So easily trap or easily abstract H minus ions from the substrate moiety. So here, so which type of compounds will be involved here? Because the hydride ion is readily absorbed by this DDQ from allylic and as well as benzylic carbons. And it is soluble in almost all organic solvents like aromatic hydrocarbons, benzene, xylene, toluene, this, and also it is soluble in alcohols. So we discussed the general reaction, how that will be removes the hydride ion, we discussed. And applications, in case of application part, the first application we will discuss, that is a dehydrogenation. So the first concept is dehydrogenation, and the next followed by aromatization, aromatic compound formation. And also we discussed that is dehydrogenation in larger groups. And also we discussed about introducing carbonyl group at allylic and benzylic positions. I think that will be completed, right? Introducing of carbonyl group at allylic and benzylic positions. Is it completed or not completed?
Yes, sir, completed, sir.
Yeah,
One example with mechanism.
One example with mechanism that will be completed, right?
Yes, sir.
Yeah.
Yes,
so
sir.
Next one is, so this is a useful reagent in steroids. So the next application, it is a useful reagent in steroids. So this is a, I think, fourth application. Application number 4, I think. First application is dehydrogenation. Second application is aromatization. Third application is introducing of carbonyl group, right? So now this is a fourth one. Useful reagent in steroids. This is a useful reagent in steroids. Yeah. So these steroids are larger groups. The bulky group here I am going to take as one of the steroidal substance. So what is the role of our reagent? The reagent ఏం చేస్తుందని చెప్పాను?
H2, H minus hydride ion and H plus both are.
హైడ్రైడ్ అయాన్ ని రిమూవ్ చేస్తూ ఉంటుంది ఫాస్ట్ గా. సో ఇక్కడ నేను DDQ తీసుకుంటున్నాను in presence of dioxin. So this is ether. So we taken this one. What happens? What is the reaction that will be takes place? So see here, dehydrogenation. Here in a case of this one, so aromatization takes place. Aromatization. So this ring will be converts into like this. So this is a possibility of the formation of ring, and here it is this one. And we get, so this group alpha beta unsaturated group. So means here DDQ is acts as a reagent that converts ketosteroids into alpha beta unsaturated steroidal ketones. Okay, this is a ketone, that is ketosteroids. Ketosteroids converts into alpha beta unsaturated ketones, steroidal ketones. This reaction will be takes place. Okay, so alpha beta unsaturated ketone. So see here, This is a general reaction. So the role of this group, for example, if is like this, the steroidal group is like this. So this is a rest of a steroidal group treated with DDQ. What we get? This is 5 alpha steroidal group. So what happened here? This is a double bonded carbon. So this is our allylic center where the hydride ion will be removed and it becomes double bond O. So the double bond insertion will be takes place like this. And similarly, we go with the 5 beta. So what is the difference between 5 alpha and 5 beta? So this is a 5 beta steroidal compound. These are the hydrogens. So which are with a wedge representation, thick wedge representation when it is treated with the DDQ. So what happened? In a case of 5 alpha, what happened? This is a favorable position. From this, the hydride ion is replaced. But in the case of here, if the group is like this, so this hydride ion is favorable. So from this, the hydride ion is abstracted. So by that, we get the product like this. So this is the difference between the two kinds of reactions. So this is takes place delta 4 3 ketosteroid. We continue this reaction with the DDQ. So the same will be takes place. That is here. The next position will be next allylic hydrogen is active. This one is active. So that's why here the double bond is formed. The rest is same. So that is about the difference between the 5 alpha and 5 beta. So if 5 alpha is there, here the reaction, this center is active. At that position, the reaction will be takes place. If it is 5 beta, so this hydrogen is an active one. Now that will be involved in the reaction. So this continuation will be takes place. Okay, so this is a useful reagent in steroids. So because of this versatility. So the next one is cyclization reactions. The next application is cyclization. The next application, cyclization. So see here, so the benzene, here I am going to take as a substituted compound. This is a diphenyl groups, and this is a one of the. So when it is treated with the DDQ, in presence of benzene, C6H6, what we get? What is the product? So which group is here? From which place the hydride ion will be removed? The DDQ will be abstract the hydride ion. So this is double bonded carbon. So at this position, there is no hydrogen. So that's why from this, there is no replacing of hydrogen. We have only one scope here. This is a benzylic hydrogen. So here we have hydrogen. So that's why that benzylic hydrogen will be abstracted by the DDQ. So that's why here the product formation, we will expect the product like this. So this is a product formation. Cyclization will be takes place in presence of a DDQ. If the structure will be like this. So the next one is here I'll go with one another example. What we get now we discuss. So this is one of the cyclic system. So here it is pH. Here also we have pH, and here it is hydrogen. So we go with the DDQ. What we get? So see here, in this case, what happened here, the double bonded carbon is there, this hydrogen will be removed, right? This hydrogen will be removed, hydrogen ion. So now here the double bond is formed. Now in this case, here hydrogen, now the one another double bond is formed here. So hydrogen, double bond. So like this, the extension will be possible here, hydrogen, the double bond. So means the aromatization will be takes place with how many number of DDQs? Form this product, how many number of DDQs will be required? Any DDQs ni use cheste ee product form avutundi. ఏం చేస్తాం? ఇక్కడ ఒక హైడ్రైడ్ అయాన్ రిమూవ్ చేయడానికి ఒక DDQ, right? Now here the double bond formation will be takes place. ఇక్కడ హైడ్రైడ్ ని, so now the double bond is formed here. So now here hydrogen, third one. Okay. So ఇది first one. ఇక్కడ హైడ్రైడ్ అయాన్ రిమూవ్ అవుతుంది, డబుల్ బాండ్ వస్తుంది. సో నెక్స్ట్ ఇక్కడ హైడ్రోజన్, ఇక్కడ డబుల్ బాండ్, నెక్స్ట్ ఇక్కడ హైడ్రోజన్, ఇక్కడ డబుల్ బాండ్, నెక్స్ట్ ఇక్కడ హైడ్రోజన్, ఇక్కడ డబుల్ బాండ్. సో మీరు అది చెక్ చేయండి, ఎన్ని హైడ్రైడ్ అయాన్స్ ని మనం అబ్స్ట్రాక్ట్ చేస్తున్నామో దాన్ని బేస్ చేసుకొని ఎన్ని DDQs రిక్వైర్ అయితే రాయండి. So this is one of the product that we expect. This is 51% of product formation will be possible. The remaining 49% of product formation is not expected one, that we will get like this. This is an unexpected product we get. So this is the remaining percentage. Get this product. So this is a 49% of possibility to form this product. So why this will be formed? Now we discuss. సో ఇది మీకు తెలుసు జనరల్ గా, ఇప్పుడు నేను చెప్పిన పొజిషన్ అంటే ఈ ప్లేస్ లో ఈ మెకానిజం ద్వారా వెళ్తే వి గెట్ దిస్ ప్రోడక్ట్. సో ఇప్పుడు దీని రావడానికి ఏంటి పాసిబిలిటీస్ ఒకసారి చూద్దాం. సో సీ హియర్, సో ఫస్ట్ మాలిక్యూల్ ఆఫ్ DDQ, ఫస్ట్ మాలిక్యూల్ ఆఫ్ DDQ, ఇక్కడ హైడ్రోజన్ రీప్లేస్ చేస్తున్నాను నేను, ఈ హైడ్రోజన్ అబ్స్ట్రాక్ట్ అయిపోతుంది DDQ తోని. సో హియర్ ఐఎమ్ గోయింగ్ టు టేక్ దట్, దిస్ ఇస్ DDQ. సో వాట్ వి గెట్, అక్కడ హైడ్రోజన్ రీప్లేస్ చేస్తే మనకు వచ్చేటువంటి గ్రూప్ ఏంటి, కార్బోకేటయాన్ ఫామ్ అవుతుంది. సో దిస్ ఇస్ అ ఫార్మ్డ్ కార్బోకేటయాన్. సో నౌ వాట్ హ్యాపెండ్ హియర్, ద delocalization is there, this will be delocalized and this bond will be broken up. It will be broken here. Here we get the carbocation formation. And here it is. Double bond. And here it is a double bond formation, because negative and positive make a bond. Here it is a positive and negative, that will make a bond here. And this is a pH group. So now what happened here, this is formed. And now from this DDQ, we get a O minus, right, QOH. So that will be added here. So I'm going to represent that one like this. So ఏం జరుగుతుంది ఇక్కడ, ఇది pH ఇక్కడే ఉంటుంది, ఈ బెంజిన్ ఇక్కడే ఉంటుంది, ఇది ఇక్కడే ఉంటుంది. So now here this is one carbon atom, next carbon atom, this one, and next carbon atom, this one, and next carbon atom, this one, and here it is pH. And here we have a positive charge, right? That will be represented with a positive charge, and OQOH. That positive charge is attacked by this one. So this will be happens. This is a structure, cyclic structure that will be formed here. 1 minute. Yeah. So this is a product we get. So this is the pH. and as well as this group OQOH. This is formed. Right, this is a formation. So now I'll go with the one another DDQ. 1 mole of DDQ, another mole of DDQ that will be reacts here. So for the completion of that, what happened here, this becomes a complete aromatization, pH, and this is like this. pH and the OUOH. So now what happened? These bonded, double bonded electrons that will be involved in a polarization. This is a polarization. So that will be attacks here, the OQH, that is at this carbon atom, this will be eliminated. So the cyclization will be takes place like this. There is a pH. And now this is a attacks like this. pH. So this is happens. So this is a slight rearrangement will be takes place. So after that, once again, the cyclization will be possible. Here it is a positive charge. Here it is a double bond and double bond. So once again, we go with the DDQ. So 2 moles of DDQ we required here. So by that, the complete cyclization will be takes place.